Uh, Good morning, grade 6. Yesterday we were talking about changes of state between solid and liquid, and we started with melting. Melting, as you know, is the process by which, or the change of a state in a state, or change of a state from from a solid to a liquid. It's called melting. And this process, if you remember, involves an increase in thermal energy. When the thermal energy of a solid, when the thermal energy of any solid increases, or when its temperature increases, it turns or changes to a liquid. And we say that particles of a liquid have more thermal energy than particles of the same substance in solid form. Any substance, in any substance, not only water, the particles of the liquid have more thermal energy than the particles of a solid. Example, the particles of a liquid water have more thermal energy than the particles of ice. The particles uh, of liquid gold, if gold is melted, the melted gold or the liquid gold, the particles of liquid gold have more thermal energy than the particles of gold or solid gold. At any substance, the thermal energy of the particles of a liquid are larger than the thermal energy of the solid. Now, we are going to talk about now about melting point. What is melting point? In any substance, in a pure crystalline solids, in a pure substances, please, in a pure substances, melting occurs or happens at a specific temperature. This temperature is called melting point. Melting point. For example, ice melt or start melting at temperature of 0. The melting point of water is 0 degrees Celsius. That means under this temperature, under the temperature, if the temperature of ice is -1 or -2 or -3, it is in solid form. When ice reaches this temperature, 0 degrees Celsius, it starts to melt. But if the temperature increases 1, 2, 3, 4, melting continues, as we will see. To understand melting point, please listen to me. Figure 3 shows, figure 3 here shows what happens to the temperature of an ice cube after it is taken from the freezer and left out at room temperature. What happens to an ice cube when you take it from the freezer and lift it outside in the room temperature? Let's see, look at this figure. Changing solid ice into liquid water. Look at this graph. This line, or this, in this side, it's the temperatures. Notice -30, -20, -10, 0, 10, 23. And do you know that -30 is smaller than 0? -30 is smaller than -20. -10 is smaller than. Do you know this?
لأنه أبعد على الزيرو.
Excellent.
So we keep it in math.
So, I mean, the temperature of when the temperature of the ice cube is 0, it is larger than -10, -20, -30. This side, this line shows the time: 0 minutes, 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25, 30, 35, 40. If you understand this graph, you will understand what is melting point and what happens to ice cube. Suppose that we have an ice cube in the freezer. Its temperature, suppose that the temperature of the freezer is minus 30. When we take the ice cube from the freezer, after 5 minutes, it is still solid. Notice, after 10 minutes, it is still solid. Notice, but the temperature increases. The temperature, after 5 minutes, its temperature becomes 25. After 10 minutes, it's between 15 minus. After 20 minutes, when you take the ice cube outside, after 20 minutes, the temperature of the ice cube becomes 0 and melting starts. Melting starts at what? At 0 degrees Celsius. Before that, notice that it is still solid. Now it starts melting. So we have, what does it mean solid and liquid? If you look at the ice cube, you can see that part of the ice cube is still solid and part of it is liquid, start to melt. After 25 minutes, the same thing. Its temperature is still 0 and part of the ice cube is still solid and other part is liquid until we reach melting completes at this temperature 0 and after 30 minutes and the temperature is still 0. After that, after for example 31 minutes, 32, 33, now the whole, after this point, after 0, the whole ice cube becomes liquid. Again, I will explain it again for you. This is ice cube. When the temperature of ice cube is less than 0 degrees Celsius, it is what? It is still, yalla, who can tell me?
It's solid. Solid and liquid.
Solid. Okay?
No, and liquid.
When the
it's
temperature becomes 0, it is
Melting point.
Starts to melt.
What?
It starts to melt.
Melting starts, so part of the ice cube is liquid and part of it
solid.
and part.
طب ليش يا أستاذ ليش الثلج لما نحط مي يعني الثلج بيطلع يعني بيصير فوق المي؟
No, okay, because as if you remember in lesson 1, when water freezes, it expands.
صح بنزل
Its volume increases, so it becomes less dense, so it floats. طيب, when the melting completes, after period of time, when the temperature continues to increase, melting completes and it becomes whole liquid. The point at which the temperature at which this temperature, the temperature that melting starts is called melting point. Before melting point, it is still solid. And this is true for other types of matters. It is true for any type of matter, of any type of pure substances. Again, this is an ice cube. Suppose that you take it from the freezer and put it outside. After, for example, 0 time, 5 minutes, it's still liquid. It's solid, sorry. 10 minutes, it's still solid. After 20 minutes, and when the temperature reaches 0, melting starts. Before melting, it is solid. Then melting continues as the temperature increases. melting continues, but the temperature of water is still 0.
Teacher.
Notice that when it is 0, part of the ice is solid, part of it is liquid, but when the melting completes after a long, for example, 30 minutes, the whole ice becomes liquid. So when we say melting point, it doesn't mean at melting point at 0 degrees for water, it doesn't mean that all of the ice melts, but it is the starting of melting. Rashid, I will give you the chance, but wait. So at first, the energy flowing from the environment or the outside into the ice makes the water molecules vibrate faster, okay, because they gain energy, raising the temperature of the ice cube. At solids melting point, its particles vibrate so fast, vibrate so fast that they break free from their fixed positions. So they are now not fixed in their positions. When the ice cubes reach the melting point of water, 0 degrees, its temperature stops increasing. As you know, as you see, when it reaches 0, the temperature stops increasing. Still 0. Okay, let's continue. Then
أستاذ عادي ترجع للهايلايت.
wait.
أيوه وقف أنا
Finally,
هسه.
at this point, added energy continues to change the arrangement of water molecules from ice crystals into liquid water as the ice melts. يعني I mean, the melting continues after 0. But you must know that melting point, we mean by melting point the temperature at which the solid starts to melt. Get it?
Yeah.
طيب خلينا نشوف مين عنده سؤال.
Teacher me.
راشد, yeah.
Yes, mister?
Do you have any question?
No. It's all fine. I understand. Melting point. Yeah, it's
آمين,
fluid.
أحمد أشرف, تيم, آدم.
Yeah, me. Teacher time.
So, by the way, you have to know that the melting point, any pure substance has its own melting point. Okay? But for water, it is 0 degrees Celsius.
Could you summarize the graph real quick?
Okay, again, Karam.
Yeah.
This graph,
Thank
the graph shows how the temperature of solid ice changes as it melts into liquid water. Notice that this line shows what? The temperature of the ice cube. Here, the time. Suppose that you take an ice cube from the freezer. At 0 time, this is the beginning, the temperature of the ice cube is -30. After a short period of time, the temperature starts to increase. Notice that -30 to -20, it is an increase in temperature, not decrease, because -20 is bigger than -30. Notice that as the time, with the time, after 10 minutes, also the temperature increases. 15 minutes, the temperature increases, but from the beginning to 20 minutes, notice that, or from -30 to 0, it is still solid. The ice cube,
Teacher, are you hear me?
temperature of the ice cube when it is -30, -20, -10, until 0, when the temperature of the ice cube is below 0, when the temperature of the ice cube is below 0, it is still solid. No melting happens. When the temperature is 0 exactly, it starts melting, starts. This point is called melting point of ice or melting point of water. And notice that after temperature of ice, when it is zero, it stops at zero. No increase in temperature. After, when the increasing in temperature, when the temperature is continue to increase, melting completes. That means the whole ice cube becomes liquid. When the temperature of ice is zero, it's a mixture of solid and liquid. Yani when the temperature of ice, when the melting starts, after a short period of time, the temperature do not increase, and the part of the ice is solid and part of it is liquid. And after a period of time, or 30 minutes, the melting completes and the whole ice cube becomes liquid. Okay? طيب. So you have to know, please, melting point is the temperature at which the solid start to change to a liquid. But it doesn't mean that at melting point, the melting completes. This is a very important point to know. Melting point, please add this note to your book or whatever your notebook. Melting point means melting what? Starts. Not complete. As the temperature rises, the melting continues until the whole solid becomes liquid. So at melting point, the solid melting starts, not complete. Melting point doesn't mean that at this point the melting completes. No, melting starts at this point. Any pure substance, for pure substances, have different what? Melting points. لا بديش بلاش تخربطوا فيها. Each pure substance, each pure substance has what? Its own melting point. طيب, what do you expect? Which has higher melting point? Water or iron? What do you think?
What? Water, I think so.
Which has higher melting point? Ice or iron or steel?
Ice.
No.
Steel, I mean.
No. Metals such as iron, gold, copper, their boiling points are very, very high. Okay? You need a large amount of energy to melt them because they are very strong. The bonds between the atoms, or yes, the bonds or the attraction between their atoms are very strong, much stronger than water. طيب, we have an activity. Go to the internet and find the melting points of different materials. Who can do this activity? Who can bring?
Me, could I do it? I could do it right now.
Who can bring for me the melting points of different substances? And we want to compare it with water.
Sir, I know one.
Which one?
Water melts at 0 degrees Celsius.
What? لا راشد.
Water melts at 0 degrees, or ice.
Thank you, Rashid. We already know this. It's written in, I mean, other substances or other materials, such as, for example, iron, gold, copper.
Yeah.
Do you have anything to add?
Yeah, iron melts at 2064.
Which one? Which?
Iron.
قديش?
Sure. Iron melt at 2064
Excellent.
Celsius or
How do you know, Laith?
By going to Google.
Oh, sorry. This is, I forget. Sorry, look at the last paragraph. Because the melting point is a characteristic property. طيب شباب, what does it mean characteristic property? طيب, to understand what is a characteristic property, that means this property does not change. You can identify any substance by the pure substance by its melting point. Characteristic property, that means it never change, no matter how much of the matter you have. I mean, melting point of water or of ice is 0. If you have a small cube or a big cube, if you have an ice cube that has a mass of 1,000 kilograms, its melting point is 0. If you have an ice cube that has a volume of 1 cubic centimeter, its melting point, that is the same thing, is 0. That means, for example, your name is Rashid. Your name is Rashid. Even you are in a school, in home, in the street, it's a characteristic property. It does not change because the melting point, please highlight it, characteristic property. Melting point is a characteristic property of a substance. Chemists or scientists often compare melting points when trying to identify an unknown material. So we can use it to identify a known material. Another examples of characteristic property, density of water, for example, is always 1 gram per milliliter or 1 gram per cubic centimeter. The density of copper is a characteristic property of copper. It does not change. If you have
the density of water, it will stay.
I mean, characteristic properties are properties that will never change. They are always the same, no matter how much you have. Example, silver and iron, both of them are metals. Both shiny, both of them shiny, and they have similar color. But how can you distinguish with them? Scientists can distinguish between them by melting point.
Melting point. For example, Mr. If we don't know if it's aluminium or iron, we melt it and we see which melting point it is.
Chemists use the laboratory. They go to the laboratory. Suppose you have a piece of silver and a piece of iron. If you look at their physical properties, if you look at their physical properties, both of them are shiny, okay? And they have the same color. So how can I distinguish?
انت رحت على البويلينج والفريزنج.
رحت على عمان. ايوه. طيب اوكي. الآن if for example أحمد أشرف وينك؟
موجود هيني.
Are you sleeping؟ ولا قاعد تفطر؟ طيب. Silver and iron, both of them are shiny and similar color. So how can we distinguish between them? By melting point. We can measure, for example, we can heat both of them and measure the temperature of at which they melt, or the melting point. Silver, for example, melts at what degree? Look, 961.8 degrees Celsius. It's very, very high. While the melting point of iron is 1,538 degrees Celsius, which has larger melting point. Which melts at higher temperature, iron or silver?
Iron.
Iron, of course. So no matter how much of substance there is, okay? Please, it doesn't matter how much of a substance there is, it will always melt at the same temperature. Please highlight this point. If you have a small piece of iron or 1 ton of iron, both of them will melt at the same temperature. No matter how much of silver, they will melt at the same temperature. No matter how much you have ice, they melt. Understood? Because it's a characteristic property. It'll never change, no matter how much you have of the substance. Melting point is a characteristic property. طيب بدي احكي لكم شغله. Is mass a characteristic property? Is mass a characteristic? No.
Yeah.
No. Because that can change. Mass and volume can change, but melting point never change. Boiling point is a characteristic property. Freezing point is a characteristic property. Density is a characteristic property. All of these are always the same. If you have an ice cube قدراس ليث أو you have an ice cube as small as your eraser, they will melt at the same point, 0 degrees Celsius, because it's a characteristic property. Understood? طيب. Tomorrow, inshallah, we are going to talk about freezing. Okay? Freezing is the opposite of what? Of melting. Freezing from a liquid to solid. From a liquid to a solid. That's enough for today. I want to end the meeting. Inshallah, يوم الخميس امتحاننا. راح نعمله بوقت متأخر عشانها عطلة. توبيك 1. توبيك 1 راح احكي.
Teacher.
اوكي راشد.
Teacher.
تفضل.
Wait a minute. You hear me last like 10 minutes?
تفضل ايش بدك تحكي؟
In last 10 minutes, you can hear me?
Yes.
Oh, okay. I think the mic is.
طيب ريان, do you have anything or any comments?
Teacher, when is the exam?
يعني time, you mean the time?
Day and time.
Okay, day Thursday. Time maybe after يعني ممكن اخليه الساعة 2 كويس؟ 2 الظهر.
But it's not at school time?
كويس.
خلاص ان شاء الله راح احدده بعدين.
Okay.
Goodbye.
Goodbye.
See you ان شاء الله.